Hi everybody, Mr. Farmer here, and today we're talking about AP Micro, the whole thing with College Board units in mind. So let's get going with Unit 1, the basic economic concepts. The focuses are the production possibility curve, comparative advantage, marginal analysis, and scarcity. We're going to be looking at the graphs though. So the production possibility curve or frontier, marginal benefit, and marginal cost. So the production possibility curve, a frontier would be the just the table for it, is we have two goods being produced. Pizza and sugar is the example here. Now this is where comparative advantage can be used, and so we can definitely look at that at a different time, but that's a different video. The blue curve here is the full employment curve. Okay, so if you're anywhere on there, you're fully utilizing your resources, and that would, second semester for macro, be similar to the LRAS, but we're talking micro right now. Point F is when you have overutilized or the unobtainable. I don't like that as much because you can get overtime, but for academic purposes, that is unobtainable. However, if you're points D or E, you are inefficient. You're underutilizing one of your factors of production, the land, labor, capital, or entrepreneurial abilities. Then we have the marginal benefit and marginal cost, which later do become supply and demand effectively. So this is a little more mathematically, and yes, I couldn't help myself. The hours of studying, it does come at a little bit of a cost. We have the increasing marginal cost curves going up this way, and we have the decreasing benefit, kind of the increasing cost scenario, and the decreasing benefit, diminishing returns, if you will. As you spend more hours, you do get less out of it, but it costs you more and more of something else. So you go into where they're equal, where marginal benefit equals marginal cost, and that's going to be the efficient output there. So not too many graphs for Unit 1, but the later ones, especially 3 and 4, we do get more. With Unit 2, the focuses are elasticity, consumer producer surplus, the effects of government intervention, mostly for the price floors and price ceilings. So these are the graphs we'll be looking at. Supply and demand, a little bit with international because it's basic economic concepts, and that does kind of fall in. You can get some international stuff, although international is much more the macro. You do still see a little bit on the first semester micro stuff though. So here's our basic supply and demand graph, and these shift for various different reasons. But this is the equilibrium. Okay, this is the average price point and the amount that will be sold for these goods. And then the supply and demand can shift around just like always. So increase in demand, shifting the curve to the right, or an increase would then increase the output sold and the price of that as well. And the same for supply, we shift those things around. For price floors and price ceilings, I know this is kind of a crazy thing up here. A price floor is the minimum price regardless of if it is effective. You can only sell at you can't sell below a price of $8. That's a price floor. You can't sell at a price below $2. That's also a price floor. It's just ineffective. So for an effective price floor, that would be a price floor above the equilibrium, in this case $5. Now, because it's a higher price, that would create a surplus of goods. The quantity supplied is larger than the quantity demanded. This, therefore, means we're not producing at our allocatively efficient level because we're not producing where supply is equal to demand. So we would have a dead weight loss in here, which is going to be this whole triangle I'm kind of rounding the corners with. A price ceiling is the maximum price, regardless if it's effective. So you cannot sell above $2. That's an effective price ceiling. You can't sell above $8. That's also a price ceiling, but not very effective. So if it's an effective, you do get a shortage where the quantity demanded is larger than the quantity supplied, so there's not enough to go around. Typical examples for a price ceiling would be something like a rent control, for instance. For price floor, typical would be things like minimum wage, or sometimes agricultural prices can sometimes floor, sometimes ceilings actually for both of those. So for international stuff, we have this. I have a little key over here. So the price on here is the domestic price. If there's no trade partners, you'd be selling it at point P and point Q would be bought. But if there is trade going on, then the world price, the world supply, is at P1. Okay. And so from Q prime to Q2, that's the amount that would be domestic supply at the world price. Okay, because at that price, only this amount of supply is willing to be sold at that point. What if they want to sell more? Well, their supply curve only intersects at that point. But the demand is way over here at Q1, so where does that come from? Well, the gap between Q2 and Q1, Q2 to Q1, that's the amount that would be imported from other countries. Here's a little bit more with this. So why would there be a tariff, for instance? Okay, the tariff would then increase the world price closer to the domestic price and give them a little bit of a fighting chance to do that. It would also give the domestic producers a little bit more. You can see it was originally over here, and now they produce that much more. Now, the tax revenue, this would be the amount that would be sold, and so at this tax revenue, this amount would go towards this, because the original world price was here, so this is the tax amount on top of that. So that's why this is the tax revenue right here. Okay, that little box. You can see the consumer surplus from gaining the import. You can see the whole consumer surplus would be this big section here. But from importing is just this smaller section, because this whited out portion would be the domestic consumer surplus. But with the imports, it does go a little bit further here. Elasticity. For demand elastic, something is more elastic, meaning people are more sensitive to price changes. So it's a flatter curve. Now this is price elasticity of demand. Elasticity of demand can also refer to just the characteristics. Is it a need? Is it a want? Is there a long or short time or lots of substitutes? This is specific to the prices that we're talking about. The inelastic side is that they are less sensitive to price changes, meaning that it's actually, they are proportionally less change compared to the proportionality of the change to the price. The price changed by 20%. Quantity only changed by 5%. Because it's demand, they'll go an opposite direction, so it will come out as a negative always, but this goes into proportionality. So for the supply, we have the upward sloping supply curve. So when you plug into the elasticity coefficient equation, which is totally accepted by Collegeboard, or the midpoint formula also works, you come with a positive number since the price and quantity go in the same direction. Real quick, I'm going to go back. For the demand, you can use the total revenue test for the demand curve, and that's because the price and quantity have an inverse relationship, so the proportional change will change if you come with a similar or dissimilar total revenue when you compare it to the price. Doesn't work for supply. You cannot use the total revenue test because price and quantity have the direct relationship. They'll go in the same direction. So if you plug in, you'd always come up with inelastic, which is not the case. The total revenue test, only for demand. So here we have the supply curve. If it's more elastic, that means they have more time to figure out, do they want to sell that good at that price? So there's going to be more on the long run time period. Where if it's more of the inelastic, that means they are not very, that they have to sell at that price. So even if there's a price change, they still have to sell regardless of what they have. Okay, this is going to be more on the short run time period. Sometimes people call it the market time period. We do focus more on the short run though. So here's the rules. So when you plug in for the equation, quantity new minus quantity old divided by quantity old, all over price new minus price old divided by price old. Okay, that would be the elasticity coefficient equation. When you plug into that, you use absolute values for demand. Supply will be positive, it doesn't matter. If it's a greater than one value, elastic. Less than one value, inelastic. Equal to one, unilastic. But for the cross and income, when you get positive or negatives, it really matters. So you need to make sure you are consistent with the quantity new minus quantity old, and on the denominator, price new minus price old. If you flip those, you come up with the wrong thing. So for cross elasticity, a positive outcome means substitute. Negative means complementary. For the income, a positive means a normal or superior good, and a negative means an inferior good. Look at the other videos to kind of go from there. Unit 3. Now we're going to get a lot more into the graphs. Short run cost, perfect competition, all that stuff. So first off, we have the short run cost curve. So we have the marginal cost curve goes down and then up, increasing cost curves there. This is also reflective of the law of diminishing productivity in the law of diminishing returns, so that as you have more and more variable resources hired, then the costs increase because you don't get as much work out of them. Okay, and that's why it goes down and then up. This would be the stages of production. Stage 1 is increasing, stage 2 is decreasing or diminishing, and stage 3 would be negative, which we don't see here. You have the ATC, AVC, and the AFC, average total cost, average variable cost, and average fixed cost. It is important to note that the average total cost minus the average variable cost equals the average fixed cost. You can rearrange this as you need to. That plays a role when you start talking about types of profits, mostly the minimizing loss or shut down. What this means is that parts AD over here, minus BD over here, equals CD. Okay, and the reason why that's important to note is that equals the fixed costs, which means part AB should also equal fixed cost, the average fixed costs. Okay, so that's going to be where it's going to play a role for it. A couple things to note. You can see I put Z on here for output of productivity, productive efficiency. That is the minimum ATC. By mathematical definition, where marginal cost crosses ATC is the productively efficient output. That is the minimum ATC. Point Y, that would be true for the AVC, average variable cost. Not that's really important, but mathematically that would also be the minimum AVC. Long-run productions, we have economies of scale, constant returns of scale, and decreasing diseconomies of scale. Okay, and so as the idea is that as you produce more, you get more and more efficient, and this is where we get to monopolies and natural monopolies. So types of profit. Those 4 types of profit, doesn't matter if it's perfect or imperfect competition, it's just always the same. So when you're at your output, you figure out your marginal revenue, marginal cost, and your profit maximizing. Then you compare your price or your demand curve to your ATC or AVC, whichever else it is. So at the profit, if you're up here at point A, this is your price. My price is right here. I compare it to my ATC. It's greater than my ATC. I'm producing at a profit. It will be this kind of box area I'm kind of circling now. If my price is B, I'm going to be producing at MR equal MC. I'm breaking even. What about minimizing loss? Well, minimizing loss is where I'm at point C. That's where my price is. Well, I'm losing money because if I go straight down and straight up at that quantity, this would be my price is less than my ATC, so I'm losing money. But you can see it's greater than my AVC, and this is where it's important to remember ATC minus AVC, so the gap between these two is my averaged fixed cost. So this means because C is above my AVC, some portion of this can go towards paying off those fixed costs. So I would still operate in the short run because I would be losing less money, hence minimizing loss, if I continue to operate. In the long run, yeah, I and other people will be getting out. And then you get to part D. That's just shut down, where you're going to eat that fixed cost because if you produce, you're going to lose more money because my price is less than my AVC. So I still have costs, I still have the fixed costs like the rent, but I'm not going to produce anything because it would simply make me lose more money. So a quick note on efficiencies before we go even further into these. So we have allocative efficiency. That's when consumer surplus plus producer surplus, I should say surplus there, that area is maximized. Now where does that happen? When supply equals demand. Or in the case of imperfect competitions, because we don't actually have a supply curve there, we'd use marginal cost equal to demand. When those are equal, we are allocatively efficient. We're producing at the socially optimum output. Productive efficiency, which we talked about before, is when a company produces the goods and services in the most efficient way. How do we know when that is? Or are they using their fixed and variable resources in their optimal efficient level? Mathematically, we know that that would be the case when it is at the minimum ATC, because the total costs take the fixed and the variable resources into account. And so if we're at the minimum ATC, that means we are at the minimum average cost of producing that that company has with its current fixed resources. Final note, it doesn't matter if my price is equal to my ATC, only that I'm producing at the output associated with the minimum ATC. So we get to the graph, perfect competition. This is where we have a side-by-side graph. Again, this is unit 3. On one side we have the industry, on the other side we have a representative firm. This firm is a price taker or price receiver because they don't really have much say. There's a ton of firms in this whole industry, and so whatever the whole industry says, that's what's going to go. So large number of competitors, and they're perfectly competitive. Same goods, same services, same everything. And so we have this price. It's going to go all the way across. That's what indicate price taker. And then my price is greater than my ATC, so we're producing at a profit. So in the long run, what happens? Again, in the microeconomics, long run means firms can enter and leave an industry. It also means you can change fixed capital. We're not focusing on that part. So what's going to happen is firms going to enter into this industry until they're at the status quo. The economy's at rest. When does that happen? When you break even. So firms enter in, that's going to drive down the demand for this firm. So you notice my supply curve, my marginal cost doesn't shift. My demand curve does. Why? There's more competitors. They're not as likely to go into this one store. So we decrease until we're at that point. Next, unit 4, imperfect competition. It focuses on monopoly, monopoly competition, price discrimination, all the fun things. So here we have monopolist competition or monopoly. They actually look like the same graph. Here's it as a profit. Here's it at a loss. So that's one mystery is, or misunderstanding is, they can produce at a loss. It's less likely, but it's definitely possible. So how do we get to this spot? Margin revenue equals margin cost. That's still the profit maximizing. So I'll go straight down, straight up. And then I do what I did before. I compare my demand curve to my ATC. Since it's greater, I'm producing at a profit, and I go all the way across to get my total profit. How about this one? Well, margin revenue, margin cost, great. Here's my demand curve, and I have to go up to my ATC. So I'm producing at a loss. Now, it says short-run economic losses, so I'm assuming my price is greater than my AVC, but if we have my AVC on here and my price was not greater than it, I would actually shut down and produce 0 units. We'll assume they'll be producing for this instance though. So in the long run, what would happen? Well, in the left-hand profit system, what would happen is more firms would enter in. What happens when more firms enter in? Same thing that happened in perfect competition. The demand curve would decrease. So this demand curve would shift down, and the margin revenue curve would also shift down until it broke even. And here, the demand would increase since firms would leave. In the long run, monopolist competition will break even for that reason. So just like perfect competition, in the long run, they both break even because firms can enter or leave the markets for monopolistic competition and perfect competition. So here we can see what that would look like. So the demand curve decreased as more firms enter in. There's a decrease in demand for this one particular firm. My margin revenue would have also decreased as well. You can see now I'm breaking even. Here's my demand equal to ATC. So this is the long run profit, also referred to as a normal profit. For monopolies, and then we have natural monopolies, which is actually unit 6, but we're going to do it here. You might hear a thing called super normal profit because we will have a profit, and we have dead weight loss. I didn't show some of the monopoly competition, but we definitely would have seen this. We have dead weight loss because here's my marginal cost equal to my demand curve. But I'm producing at my market output, so I'm not producing at the market output, at the social optimum output here. Okay, this is why it's called imperfect competition, because they aren't producing at that level. I'm going to go back quite a ways. Here we're producing at supply equal to demand. I'm producing at my allocatively efficient level. So perfect competition is allocatively efficient. Also, in the long run, they're producing at that minimum ATC, so they're productively efficient. Even in the long run, they're not producing at the minimum efficiency, marginal cost equal to ATC. So this is why they're referred to as imperfect competitions. They're not allocatively efficient, nor are they productively efficient. For the natural monopoly, also referred to as the regulated monopoly, we have the profit maximizing, that's monopoly price, marginal revenue, marginal cost, and go from there. We also have the fair return price. Fair return price is the break-even price. That would be the ATC equal to demand. And last one of note is the socially optimum price or output. That's going to be where the marginal cost equals demand. So for price discrimination, the most common thing that pops up is a thing called perfect price discrimination. This is where the business is able to somehow charge each customer the exact amount that they're willing to pay. This essentially means that the demand curve and the marginal revenue curve are now equal, because instead of having to charge this PC level or this PM level to all customers, for this first customer, I'm charging them a whole bunch. For the second customer, I'm charging them a little bit less, but the first customer, still the large amount. I'm going to go all the way around, which means I don't lose the marginal revenue for the previous clients, previous customers, because I discriminate on the price. I charge different prices. For whatever reason I'm able to do this, we'll just kind of go with it. So how much would I produce at this point? Well, I produce where my marginal revenue equals my marginal cost. Where does that occur? Well, again, now, because of the price discrimination, my demand equals marginal revenue. So marginal revenue equal to marginal cost, there. Okay, so I'll be producing at QC. And then this big triangle would actually be my total profit, because my average cost is right here, but my prices are all of these sections now. So this whole triangle would then be my area of profit. Don't think I've ever seen the question, but that's what you end up being. So you do base times height divided by 2 if that does pop up for that. So you can see here my marginal revenue is now equal to my demand, and then the area of profit here in green. Oligopolies. Okay, so this is where you compare, you have the dominant strategy, sometimes you get the Nash equilibrium, and I do recommend you guys watch this video. It really does go through all the different scenarios, but this is where you do kind of the big game of what if. Okay, what if all players know all the information and they choose independently? Would player A choose be point X or point Y? What they do is they compare what player B would do. Okay, if player B picks X, player A can pick X and get 4, or pick Y and get 3. Well, 4, we'll assume this is a profit, is better, so they pick X. What if player B picked Y? They get 1, X and 1, or Y and 2. They'd rather pick 2. Okay, well, first they picked X, now they pick Y. So they don't have a dominant strategy here. Okay, well, how about next? What if player A picks X? Player B can pick X and get 6, or Y and get 5. Okay, and so you keep going through this process until you can figure these things out. Okay, so again, watching this video I think is helpful, so you can click on that. So the factor market, unit 5. Okay, factor market, supply and demand, profit maximizing, mostly labor. So here we have perfect competition. So again, we have a side-by-side graph, but here the supply are the workers and the demand are the business owners because they demand the consumption. And we have a thing called MRP, marginal revenue product, and you can probably compare that to your marginal resource cost or marginal factor cost, MRC or MFC. We're going to hire where my MRP equals my MFC, so we'd hire a point Q amount of people, and we're going to pay them what the wage rate would be. On the imperfect competition, we have a little bit different. This is where there's only one firm hiring, and so they're the monopsonist hiring firm or imperfectly competitive firm. So the supply is people are willing to work for this amount. But because I have to face this upward sloping supply curve, because I'm facing the industry supply curve, whereas before I was facing, hey, if you're working this industry, you're getting paid this amount, and the whole industry dealt with this industry supply, and I just got told who was going to work with me. Here, the firm itself is dealing with the whole industry supply curve over here in red. So that means the MRC, marginal resource cost, is going to be that much higher. It's going to be above the supply curve. So I'm still going to hire my MRP equals MRC. So it goes straight down here. Okay. And then I'm going to hire the QM level of people. Now, one thing I want to point out is I added in this gray curve right here. This would be if you're acting in perfectly competitive labor markets, supply equal to my demand, the MRP. And we do this to recognize that the monopsonist is going to hire a fewer amount of workers and at a lower wage rate than if they're in a perfectly competitive firm. That's something to acknowledge. Last unit is Unit 6. Market failures and the role of government. Externalities, public goods, effects of government intervention, inequality. It occurs with the externalities. Lorentz curve, which actually isn't on the test anymore. Natural monopoly, which we already covered, so I'm not going to go over that, but that is part because it's called the regulated monopolies. And then supply and demand when you add in taxes. So for externalities, we have positive and negative. So we have the marginal private cost or marginal private benefits. And if it's a negative externality, then there is no surplus benefit to a third party. So the marginal private benefit and social benefit are equal. But when you add in a negative externality, I mean a higher cost to society, marginal social costs appear. So now you can see we have this dead weight loss because we want to get the socially optimum output, which is marginal social cost equal to social benefit. And for a positive externality, you can see we're under consuming, they're under producing, under allocation of resources because we want to be producing more, so there's an external benefit to society. So overproduction or over-allocation is associated with negative externality, and the under-allocation is here. You can correct these with things like public goods being offered in the case of positive externalities, subsidies either increase or decrease depending if you want there to be less or more stuff produced, or changes in taxes accordingly. Last thing is government intervention. Now, a quick note for elasticities, whoever is more inelastic will have the higher burden of tax. That's just going to be our statement. What I wanted to show you is the tax revenue when you look at this. So we have the supply and demand without the taxes, and then when you add that in at the output of the new supply curve, which is supply with taxes and demand, that's the market output. The firm, the original corporation or business, would charge this amount, the original supply curve. On top of that is the taxes. So the gap between the supply and taxes and the original supply curve and over would be the then tax revenue. Okay, so that was all the 6 units for microeconomics. Hopefully that helped. Until next time, bye. I'm going to pay them. I'm going to pay them what they said they were willing to work for, which is the supply curve. So I'll be paying them a wage rate of this,